So I want to go over the gas laws that you did the past couple days. In class, we did some investigational labs, so we'll label this gas law. The first one that we did was the syringe, the plastic syringe and pressure, where we used the pressure gauge that was connected to graphical analysis, so we'll just label that graphical analysis. Now what we saw happen was as we had a volume manipulation, we manipulated the volume in that syringe, so we were pulling it out and we were increasing the volume, and we had a change of pressure. We did not manipulate the variable temperature, we just held this constant at room temperature, so we're just going to write down that temperature was constant. So I'm going to write down over here what we actually did. So as the volume went up, what we noticed on the graphical analysis data table is that the pressure went down. This relationship is called an indirect relationship. So kind of make a table of the investigational labs that you performed in class over the last 2 days. We have volume and pressure are the two variables that were used. The mathematical equation for this is Boyle's law. PV is equal to PV. So this means as volume went up, your pressure went down, and this is the mathematical equation for this relationship. The second one you did during that day was the water temperature. We changed it from ice water to room temperature to possibly boiling water, hot water, and we used changes of water with our huge pressure gauge. So we had temperature and pressure that were being manipulated or changed, those two variables. Volume was held constant, so I'll write down volume was constant. So we will rewrite that and say temperature and pressure. So what we saw here is that we increased temperature. As we increased temperature, we noticed the pressure also increased. And this relationship is called a direct relationship. The difference being that the mathematical equation would look like this. P1 over T1 is equal to P2 over T2. And the next day we had 3 more investigations that we did. I'm going to move my camera down a little. We had the can cut crusher. I'll label it can crusher. In this case, we manipulated temperature and the variable volume, and our pressure was constant. What had happened is that we took the pop can, we put it on a hot plate, we increased the temperature, and then we quickly inverted it and decreased the temperature. As we decreased the temperature, the pop can imploded. So the volume decreased, it imploded on itself. So we had a temperature and volume were the two variables, and this is a direct relationship. As the temperature decreased, the volume decreased, and our mathematical equation would look like this. V1 over T1 is equal to V2 over T2. The second day we also did a investigational lab where I gave you water balloons and a flask. In this case, temperature and volume are the two variables also, and your pressure was constant. So I'll write temperature and volume. We know the temperature and volume is a direct relationship, so we'll write that, and let me explain what happened. So what happened is in the flask, we lit a match, we put it in, so the temperature was hot. When we put it in and covered the lip with the water balloon, the temperature dropped, and thus the volume of the water balloon also decreased, and it was able to be then pulled into the flask. So the math involved with this would be V1 T1 is equal to V2 T2. Then we did the tater gun. I did this as a demonstration, potato gun, and pressure and volume of the two variables, and temperature was constant. So I'm going to rewrite those words, volume and pressure. And this is an indirect relationship. We found this out from the very first investigation that we did on the syringe and the pressure graphical analysis. So what happened in this is that inside the tater gun, the volume decreased as we pressed that tater gun. So when we decrease the volume, our pressure increases, and that little piece of potato then shoots outward. So the math involved is P1 V1 is equal to P2 V2. If we were to have nothing held constant, none of our variables held constant, we would then label it as a combined gas law, where we have P1 V1, and we also have the relationship between pressure temperature, and we also have the relationship between volume temperature. So P1 V1 over T1 is equal to P2 V2 over T2. So although I haven't mentioned the scientists involved in developing, figuring out these relationships between these variables, the first one, our volume pressure, was Boyle's law. Then we had our temperature pressure, which was Gay-Lussac. And then we had our temperature and volume, which is Charles' law.